Good afternoon. This is Tina. How's your weekend? I'm still very busy during weekends. Okay, probably I'm gonna next weekend it's gonna be a little bit better. But in the past 2 weeks, I was really tired on recording so many videos every week. And anyway, let's start. This video we're gonna talk about the compound index, which is a single index structure and holds reference to multiple fields within our collection. Now let me give you example. Okay, here in our TestDB, and in the products this collection, and this is the structure of each document, right? And now suppose I create index. This is the default index created in the collection, okay, using get index only has a primary key. Products.create create index, and now we will create index using two, we're using this one first, then using this one. Okay, manufacturer, okay, and we're using ascending, and we're using price, which using descending, like this way. So now after I create this index, this single index will hold the reference to multiple fields, which in this case is manufacturer and price within our collection, right? So this is called the compound index. Okay, now we're using get. Now you will see the index, this is primary key, and you see this the second index which we just created, which hold the manufacturer and the price. Okay, this is ascending and descending. So this is called a compound index, okay, which is you have a single index, like I have this single index, but hold a reference to multiple fields in our collection. And MongoDB has a limit on the compound index, which is for this compound index, the maximum fields you can hold here is 32. Okay, and when using the compound index, it has some kind of like way, okay, which sometimes your queries will supported by the index, but sometimes doesn't support. Let me give you one example. Let me using another one. Okay, compound index. Okay, so here I copied the documents to be here, so I don't need to you know, okay. I wanted to make it larger. Okay, done. Okay, just do like this way. Okay, I'll have to do like this way. Okay, it's larger now. So now let's using the index we have. Okay, so if I create index like this, like the key, manufacturer, and which is ascending, and price is descending. So first, our records gonna be sort by manufacturer, which is ascending order first, and then within the price, within each manufacturer, okay, within each manufacturer, it's gonna sort by the price, which is descending. So here in our example here, let's see how index hold a reference to our documents. Okay, so we go back and we go here. Let's using the black. Okay, and here this is our index, which start from minimum to maximum. Okay, and now we have to sort using the manufacturer value first, and this is ascending. So here gonna have Apple. Okay, and then here we'll have our Google, and within this Apple then it's gonna sort by the price, okay, and which is in descending order, which you're gonna have the ID price. This is a price, okay, then 600. We're using descending, right? Descending gonna be Apple. This one is 900. Then I'm gonna have price, which is 800. Then I'm gonna have price 600. And for Google, if we have more products, it's gonna also sort here first. So we're gonna have price 500 because we only has one. Okay, so this is a compound index. First sort by we create an index like this, right? Create index. Create an index which is by manufacturer one price -1, right? This is what we used. So it was sorted by Apple, which is the manufacturer. Apple, Google, Apple. Here, if I have Facebook, it's gonna be Facebook. Microsoft, then Microsoft, like this. Okay. Then inside each of the manufacturer, it was sorted the products based on their price. Okay. This is each of the index. This is our index structure, and it hold reference to our for our documents. So now if I have a query like this, okay, if here I have a query called db.products.find, I want to do a sort, okay, sort, and let me make it to be here, okay, dot sort. I want to sort by manufacturer, okay, using ascending, and the price is descending, okay. And for this query, it's gonna using our index, because we have an index here, which is a manufacturer is ascending and the price is descending. So when we do this query, it's gonna using index to make sure our query gonna be faster. And with which order? Just using this order. Okay, sorry. He just using this order, which is the manufacturer is ascending. Then inside each manufacturer, the price is descending. Okay, and also if we have another query like this, db.products.find .sort, and if I using sort, which is based on manufacturer dot -1, which is descending, and the price is ascending, then it gonna still work, because MongoDB can do the can traverse our index in either direction. Okay, so for this one, MongoDB will traverse our index using the reverse order, which is from maximum. So here, take a look at here, the manufacturer value. The manufacturer value is is the descending, right? And also in each manufacturer, like here, in each manufacturer, the price is ascending. See here. So for this query, still we are using our index. Okay, either way it works. But if I make a query like this, db.products, here I have my photo, so I will have scroll up a little bit. Okay, products.find and .sort, and now if I using manufacturer, which is ascending, and the price is ascending, or if I do like this, products .find, and I using .sort based on manufacturer is descending, price is descending. And for these two query, I using this one. Okay. For these two query, okay, it won't using our index because our index doesn't support these two query. Because take a look at, I want to sort my manufacturer using ascending, so it's gonna be this. It's gonna be this way, right? It's gonna be this way. But inside my index, our price is in an ascending order. It's not. Our price is in a descending order. It's not an ascending, so it doesn't support. Okay, and for the second query, this one is manufacturer is descending. Okay, I will go this way. Manufacturer value is descending. Now it works, but within each manufacturer, I want my price also descending. This one. Manufacturer. And okay, sorry. Yes. I want my manufacturer is descending, so which is this way. I have descending. But for the price, if go this way, it's ascending. Got it? It's ascending. It's not descending as we want. Got it? So this two doesn't work. Let's go over again. Okay. Why this two doesn't work? Because if we want to go through this direction, both of the manufacturer or price, you must go through this from the left, from minimum to the maximum. So here for the first sort, I want to manufacture is ascending. So my order is this one, right? Let me using another color. My order is let's using pink. Okay. My order gonna be this, right? Then, but when I take a look at our price, if I go this way, the price is ascending. But now here I using my price here is descending. But here I want to using ascending. Doesn't work. Second, for this one, manufacturer I want to descending. So MongoDB we're trying to traverse this way, which is manufacturer is descending. But here my price I want to using ascending, but go this way, our price is ascending, not descending. So it doesn't support. If you write a query like this, it won't get a benefit of the index we created. Okay, it doesn't matter for the single fields because we only has one field, but it matters for the for the compound index. And also there another kind of query. Let me show you another query. Suppose here I using db.products.find, and now I using sort. You no need to sort. Okay, suppose I using find. I want to find manufacturer. Okay, I want to give value which is Google. So I have this query here. Will it using our index? Yes, it will use, because our index, the component index, it will start with the manufacturer, sort by manufacturer first. So here it's gonna using our index, okay, which is they were using index to find a Google, okay. But if I have this query products.find, and here I want to find all the products which price is 600. In this case, will it use our index? Will it using this index? No, it cannot, because in order to using the price, okay, it has to go through the manufacturer first. So with this index, with this query, it will not get any benefit from our compound index, but this one is fine, okay, because the first level is the manufacturer, okay. And another thing is when we're choosing the manufacturer, when we're choosing the order in our index, it's gonna be have different performance. Suppose db dot products dot create index. Okay, and here what I'm gonna do is here I using let's see, it's very hard to give this example. This example gonna be a little bit hard. Let me think about it. Okay, this is gonna be a little bit hard. Okay, this one gonna be a little bit hard. Let me using another one I used in my class to give you the demo, because it's gonna be more vivid for explain this, which is, suppose now I have a log, this collection. Okay, in the log collection, what's the value in the log? The value is a type and the date. Okay, type gonna be the save. Okay, save operation, it might have others. Okay, so type date, and let's give a time. Okay, save and date, type is date. I did a save operation on date is 2020 01, and the time is what time. Okay, I have update and made on 0101, and I have delete. Okay, made on 2020 0102, and I have a save made on 2020 0103, and save update I have a read. Okay, read 2020 0101, or have up delete on 2020 0203. Okay, this is our records. Okay, or this is our documents in this log collection. And now I want to create a compound index based on the type and the date. Okay, so you have two choices, which is like this. We can create index. One is using like I don't care about ascending descending. What I care about the order. Okay, we can choose is type 1 and date is ascending, or we can create index based on these two, date 1, type 1. Okay, so what's the difference between them? The difference is, let's see, using the first one. Let's using the first one to actually create the structure. See, okay. So as we know, the type of the operation, okay, gonna be limited, right? The type of the operation, which means, suppose this is my first index. Let's using this is the first one. This is the first one, okay. First one. Then we sort by type using ascending. This part is a minimum. This part is a maximum. Okay, let's sort first, which has the delete first, right? Here gonna have our delete. Okay, and then gonna have the A, B, C, D, E, F, G, H, I, J, K, L, M, N, U, V, W, U update, U, V, W, R, S, then read, and then save. Okay, and then what's gonna do is inside the delete, I'm gonna using the date is ascending, which means 2020, then delete, we have delete what? Delete here 01, 02, okay, and we have another 2020 02 03, right? Delete. Okay, and then within the update, we have only one, 2020 01 02, and we have read is 2020 01 02, and we have save is 2020 01 01 2020 01 03, right? But when the time goes, how many values gonna be each of the delete and update and read and save. How many values? You will see lots of them, right? Because 1 year we have 365 days. So probably here you have at least 300 like per year, okay? At least like over 300. If as a long time goes, the delay in each of the delete, update, read, you're gonna expand. Now, if I want to find a specific log information, which is here, okay, which is like delete or read, how many records you have to find? Suppose I want to find this one. Okay, and now before in the delete, we also have the year for 2016, 2017, 2019, 2000, lots. So I will filter, I will using this index we created, this index, first find a delete. Then I have to query all below this delete to find the actual records we want, okay. This is one way, right? Let's take a look at the second way. Second way, which is date first and then the type, okay. Date first, second way, okay. And we still have the minimum and the maximum, okay. We use date first. Suppose here is 2016 001, okay. Then inside here, you will have many save, update, delete, you have lots, okay. Then you have 2016 like 01, 02, and same for update or delete, okay. And you have here we have 2020 01, 01, okay, and we have a delete or save others, okay. And we have like here 2020 01, 02, and have many, okay, like this way. Sorry. This order I made it wrong. Okay, this order. Okay, I have to using the delete. Sorry. I have to using delete first, then delete, then update. If I have save, then I have save. Okay, and let me remove this one. Okay, sorry. Okay, it has to be the order. Okay. So now, same question. I want to find the 2020 on January 2nd and which delete. So I just go to this 2020, right? 2020, and then go here to find the delete if it here has, okay? And now, based on these two structure I draw to you, based on this structure and this structure I draw it here, and when I want to find a particular log, which one do you think is gonna be faster? I think all of you guys will point to this one. Why? Because here the for the operator here is so limited, right? We cannot filter so many. And then when you go to each of the delete here, as the time goes, you're gonna search lots of records as kind of like a no use of the compound index. But here when we sort by the date, okay, it's kind of like the first level you limit the search, okay, and the second level you also limit the how many documents you need to search. So that's a problem. When we choose the compound index, the order matters. So the first key, we are trying to make sure our value of this key is as many as possible, not like a limited. Okay, not like limited, like a type is limited. It can be as many as possible. So our records gonna be spread in different, okay, in the index structure. So it can be faster when we do a search. And this is similar idea like when we put the records in the hash map. Is it called a hash map? I think it's a hash map. Okay, if our key, because in the hash map, we have a key value pair, right? And when we do a search, we are trying to using the hash key, right? If the hash key has more variety, it's gonna be faster to look up our records. If it's one, then inside the hash map, that one slot, you have to go through a linked list, because it's possible two key has the same hash code, have the same value of the hash code. So our hash code should be as a variety as possible. So we don't need to, under each hash code, we don't need to go through the linked list. Okay. Anyway, that's all from me about the compound index. And if you still have questions, you can go to the official document. They also explain those things, or you can watch other videos. Okay. And thank you for watching this video. I hope you understand compound index well after this video. And see you. Bye bye. Enjoy your weekend.